going to look at something called Riemann sums. And to start this, we're going to start with a motivating example. So I have this function v of t equal to 4 plus 7t plus 3t squared, and we're going to assume that this is the velocity of a car. And we want to know how the change in the position in the first 5 seconds. So we want to figure this out, and keep in mind velocity is changing, so we need to kind of break it up into these small increments. So let's suppose I have my time 0 to 5. And the idea is I want to see how far the car has moved from here to here, and then from here to here, here to here, here to here, etc. I'm going to keep going all the way out, and then I'm going to add all of these up. And let's suppose we want to break this up into 50 subintervals. So we're going to look at 50 little spots and see how much the car had changed in that position, and then we're going to add all of those up. The first thing we're going to do is realize that we're looking at 5 seconds using 50 little subintervals, so the length of each one of these segments is 5 divided by 50, which is 0.1. And I'm going to use notation called delta t to represent this, so I don't have to repeatedly write 0.1. Instead, I'm going to write delta t. So the idea is I'm going to try to estimate what the car's velocity is in the first little spot, and then the second spot, third spot, etc. And for each one of those, position is my rate times time. So for each one of these little areas, my little first area, I'm going to have the velocity during that spot times my time, delta t. I'm then going to add up the second subinterval by its time, the third velocity by its time, all the way up to the 50th velocity and its time. So when I do this, you can see that I'm getting a summation. So we're going to abbreviate this, k equal to 1 to 50 of v sub k delta t. So in order to add these up, we need to know what these v sub k's are. So if I think about it, my first interval stops at 0.1. So I'm going to try to find v of 0.1, and that's going to be v1. The next interval goes to 0.2, so that's going to be v of 2. V of 0.3 is going to be v of 3. And in general, I'm looking at k delta t is going to be v of k. So now I have a basic idea, and I can start to look at summing this. So here's all the information I have so far. I have my velocity function. I know that v of k is v of k delta t, and I'm looking at the sum of v of k times delta t. So let's start trying to evaluate this. Well, my v of k is going to be 4 plus 7 k delta t plus 3 k delta t squared, all times delta t. And now we can try to simplify this just a little bit. I now have the summation of 4 delta t plus 7k delta t squared plus 3k squared delta t cubed. And now I want to add all of this stuff up. So first, delta t is just a constant. We know what that value is. So that sums up to 40 delta t times n, which in this case is 50. The next one, 7 delta t squared is my constant, and then I have to sum up k. And the abbreviation for that was n times n plus 1 over 2. I then have 3 delta t cubed, and then k squared was n plus 1, 2n plus 1, all over 6. And now I just need to add all of this stuff up. And when I do, I get 418.025 once I substitute that value in for delta t of 0.1. So now I have how far my car moved, and I didn't do units here. If my velocity was in feet per minute, then I would have moved this, or feet per second, I would have moved this many feet. If it was miles per second, this is how many miles I would have moved. So I think in this case, feet per second sounds more appropriate, so we'll say that.